Hey, how's everybody doing here? Let's continue on here in Algebra 2. We're talking about absolute value functions, section 2.7 in the book. Probably a good idea if you got that out and kind of follow along with, get these notes down. Make sure you understand some of these terms and things we go over today with the graphing of the absolute value, because we're going to see it again when we go into quadratics, when we graph square roots, cube roots. Any graphing that we do throughout here is going to be based on what we do right here. So this is going to be huge for you, so let's make sure we get it. I want to start here talking about the graph of the absolute function. Here it is as an equation. F of x equals the absolute value of x. That's the parent function if you want to think of it like that. The graph is a v. Okay, when you graph absolute value, it's a v. And I'll show you a graph here on the next slide. Here we have the vertex at 0, 0. Okay, that's the maximum or minimum point that a graph's going to have. If it opens up, then it's a minimum point. If your graph opens down, then that's a maximum point. We have an axis of symmetry here, and it's just that. It's a vertical line that goes through the center, goes through the vertex, and it splits that graph exactly in half. So you could fold it up on itself and it would match perfectly. And then here's the graph right here. And if you think about it, you notice how it goes up both ways. If you put 0 in here for x, the absolute value of 0 is 0, so y would be 0. So you get 0, 0, your vertex. If you made this the absolute value of 2, if x was 2, it would be 2. You'd have 2 equals 2, 2, 2. If x was negative 2, the absolute value of negative 2 is positive 2. So you'd have the coordinate negative 2, positive 2. Negative 2, positive 2. So you can see why it juts back up, because y always has to be equal here. Remember, f of x is y. It always has to be a positive because you're taking the absolute value of this right here. So whether x is positive or negative, the absolute value of it is always going to be positive. Okay? So make sure you get that axis of symmetry. You're going to see that again with the quadratic as well as the vertex. Okay? So axis of symmetry cuts the graph in half. The vertex, it's a single maximum or minimum point of the graph. Here's an example right here. If you have the function absolute value of x minus 4, we can make a simple xy table here. Plug in any numbers that you want for x. I chose negative 2, 0, and 2 like I did in the other example. Y, or f of x, equals the absolute value of x minus 2. Just plug in the negative 2 in for your x. You end up with 2 minus 4, because the absolute value of negative 2 is 2. 2 minus 4 is negative 2. So you got the point negative 2, negative 2, negative 2, negative 2, there it is. Plug in 0 for x, you get 0 minus 4 is negative 4, 0, negative 4. Plug in 2 for x, the absolute value of 2 is 2, minus 4. How about we make that negative 2 again. And there's that point right there, so there's your graph. Okay? Now, this right here is what I've been talking about. This is the big part you got to get. The translations, we talked about translations here in the last section. It's the movement of your graph, right or left, up and down. Okay? You recall in the last section in the work we did in class, I said that if you added something to the equation, you move the graph or the vertex up. We always start from the origin, which is what we do here a lot of times too. If you subtracted something from the equation, we went down. If you added something to the x inside the parentheses, you moved right or left opposite. If you added, then you moved to the left, and if you subtracted, you moved to the right. And that's exactly what happens here. Here is the general equation for the absolute value function. A times the absolute value of x minus h plus k. K is what moves the vertex up. If it's positive, you go up that many places from the vertex. If it's minus k, then you're going to go down, just like we did here. See the minus 4, and we went down 4 places. Okay? The h is inside with the x. You move it to the right if you have a minus h, because the general formula here is minus h. So if you put in here x minus 2, really our h is 2, so you move 2 to the right. You just got to think opposite of it. So if it's minus the number, you're going to the right that many places. If it's plus h, you're going to go to the left h places. Okay? And I'm going to show you some examples of this. the A is kind of like a slope, okay? It's the vertical stretch of our graph. If the A is bigger than 1, then it's going to get steeper. You're going to get, you think about slope, get steeper. The bigger the number, the steeper the line. So it's kind of like that. If A is between 0 and 1, then it's going to be flatter. You think of a line with a slope of a half, it's flatter because 0 is no slope. 0 slope is flat, horizontal. So then, by taking this right here, that HK is the vertex. Okay, that's where your new vertex ends up going to as you moved it from the origin. Okay, so make sure you got that down. That right there is big. We're going to see this 4 or 5 more times throughout the year. Okay, let's look at some examples. All right. Y equals the absolute value of x plus 2 plus 3. With what we just said, this tells us right here we're going to move up 3 places, and since it's minus, we're going to go to the left 2. All this starts right here at the origin. So from the origin, I'm going to go to the left, and I'm going to go up 3. I've got a positive 1 here, so that tells me that I'm going to open up. So I'm just going to draw my V right here. Okay? I'm not going to get real picky about exact points. If you want to know the exact points of that line and exactly where it would go, you can plug in values for x and find the y's and do all that. But we're not going to do anything in here where we have to know exactly, exactly where that V goes. Just as long as you have the vertex in the right place and you got it going up. If it's positive, down if it's negative, we're in good shape. Okay, and you got a V. Here, nothing is added or subtracted, so we're not moving up or down. Nothing is moved or added or subtracted in here, so we're not moving at all. So our vertex is going to stay right here. But notice our A value, it's a half. Okay, that's between 0 and 1. So we're going to, and it's positive, so we're going to open up, but we're going to be flat, or flatter than we would have been with a 1. Okay? Here, we're going to go down 1. We're going to go to the right 2. And we're going to open down because that's a negative. Okay? So from our origin, I'm going to go down 1. I'm going to go to the right 2. There's my new vertex. I'm going to open down. There we go. I'll take that for an answer all day long. Okay? So, add or subtract, up or down. Positive, go to the left. Negative, go to the right. Opposite of what you would think. If it's positive, open your graph up. If it's negative, open your graph down. And the steepness factor here, if it's between 0 and 1, it's flatter. If it's 1 or greater, it just makes it steeper. Okay, a steeper V. So there's some basic examples right there. We're going to do more of this work in the classroom here over the next couple of days. Make sure we get this down. You got any questions, bring them with you tomorrow. Let's get them answered up, and we'll get started on this with some problems in class. All right, see you then. Have a good one. Bye.